Again, welcome to calculus class. In these lectures, we're going to cover the derivative, constant, and power rules. So our main objective is to find the derivative of a functions using the constant rule, using the power rule, and also using the constant multiple rule. So we start with the constant rule. Now, in our previous lectures, we used the limit process to find the derivative of a function, but that's a very long process because in this case, again, we have to do a lot of multiplication, division, arithmetic operations. And now the easiest way and also the fastest way to find the derivative of a function is to use the derivative rules. So here we start with the constant rule first. Now a constant rule means the derivative of any constant value is 0. And that's what is given here. Derivative of xc d dxc is equal to 0, which means derivative of c can be any constant value, is 0. So let's see example here. Derivative of 7, the answer is 0. If f at x equal to 0, then derivative of f at x is also 0. And if y equal to 2, again, 2 is a constant value. So derivative of y, which is dy dx, is also 0. Now, if g at t equal to -3/2, again, -3 divided by 2 is a constant value. So derivative of g at t also will be 0. So next, let's go to the power rule. The power rule here, let's assume n is a constant value. So d dx, x to the power n, the derivative of this function, if the function is x to the power n, it will be n times x raised to the power n minus 1. Now, if we have derivative of x, which means s is raised to the power 1, the answer will be 1. The reason why we are using the same rule here, since 1 is the exponent, we multiply 1 by x, which will give us x. Now, the exponent is 1, so 1 minus 1 will be 0. So s to the power 0 will give us 1. As we know in college algebra, any value or any variable raised to the power 0 is 1. So now let's try one more example here. Here they say we should find all the points on a graph of f at x equal to s cubed plus 3s squared minus 45x plus 4, where the tangent line is horizontal. So the first thing we do, we know that horizontal line always have a slope of what? 0. Here we say that all the points, the tangent line is horizontal. So this means first we're going to find the derivative of f at x. Then we are going to equate it to 0 because our goal is to find all the points on the graph of f at x where the tangent line is horizontal. A slope horizontal line is 0. So now, instead of using the limit process, we can see s cubed is a power rule. 3s squared, we say also power rule, but this will be multiple and power rule or a constant value power, and we will discuss that. Then 45x also, and we have a constant value. So the derivative of this function will be 3x squared. Then 2 times 3 will give me 6x because 2 minus 1 is 1. Here we say 3s squared because 3 minus 1 is 2. So the exponent will be 2. Now we have 45x. S is raised to the power 1. So 1 minus 1 is 0. 1 times 45 is 45. S to the power 0 is 1. So we get 45. Then as we said, derivative of a constant value is always 0. So our answer will be 3s squared plus 6s minus 45. Now here we are looking for all the points where the tangent line is horizontal. So we are going to write 3s squared plus 6s minus 45 equal to 0. Then we can factorize this equation here. So we are going to get 3s squared plus 6s minus 45 equal to 0. 3 will be common, so we take 3 out. And we get s squared plus 2s minus 15 equal to 0. 3 is common in all the three terms here. So here we can factorize this trinomial. We know 3 times 5. We are going to use, since we have positive 2 here, we are going to use, again, negative 3 times positive 5. And that will give us negative 15. Then negative 3 plus 5 will give us positive 2. So that means this will be our binomial 2. So this means s plus 5 equal to 0. S will give us negative 5. S minus 3 equal to 0. So our answer will be, we can only, on the graph, when the tangent line is horizontal, we have only 2x points. At negative 5 and at 3, the tangent line will be horizontal. The whole concept here is we are learning how to find the derivative of a function using both the constant and power rule. So we'll see more examples. So let's see next example. They say we should find the derivative of the following function. F at x equal to 4x to the power 5. So here we multiply 5 by 4 and then 5 minus 1 as the exponent. So we get 4, 5x to the power 4. So our answer will be 20x to the power 4. Now let's try the second one. G at t equal to half t squared. So we keep the half, then 2 times t, 2 minus 1. So we get half 2t. Now half will cancel 2, so our answer will be t. Then C, we have P equal to 5 divided by square root of Q. So we can rewrite, again, anytime we have a radical sign, it's good to rewrite the term as an exponent. So we know square root is half. Since, again, square root of Q is a denominator, when it comes up, it will be negative. So it's the same as writing 5 times Q to the power negative half. So we use our power rule. We get negative half times 5. Then the exponent will be negative half minus 1. And that gives us negative 3 by 2 as the exponent. And 5 times negative half will give us negative 5 over 2. And we want to change our exponent to a positive value. So we bring the Q down again. And we know half is a square root and Q to the power 3 because we have 3 here. Next example, find the derivative of the following function. The first, we have u at s equal to s to the power 8. So our answer will be 8 times s to the power 7. So 8 times s to the power 7. We multiply the exponent value by x. Then we subtract 1 from the exponent value to be the new exponent value. So it will be 7. Let's try the next question. P equal to q to the power 2/3. So here again, we are using the power rule. So we get 2/3 times q. Then the exponent will be 2/3 minus 1. And that's what we have here. The derivative of p dq is 2/3 times q to the power 2/3 minus 1. And that will give us 2/3 times q to the power negative 1/3. So if we like, we can bring the negative 1/3 down to turn it to positive. So we have 2 over 3 times q to the power 1/3. Now, what we see with the radical sign, or most of the time, when we have a variable at the denominator, it's always good to rewrite the expression so that the variable will be at the top or to be a numerator. So here we say before differentiating the function y equal to 1 over x squared, you should rewrite 1 over x squared as s to the power negative 2. The goal is again to bring the variables up. Now, if we have a constant value at the down, we always leave the constant value, but the variable is good. So example given here, we have y equal to 1 over s squared. I want to find the derivative of y. So the first thing we do, we rewrite the equation as y equal to s to the power negative 2. Then we find the derivative of y, which will give us negative 2 x to the power negative 2 minus 1. So that will be negative 3 to the power. Then it's good always to change the variable exponent to positive. So we bring the s to the power negative 3 down. So our answer will be negative 2 divided by s cubed. Next question says we should find the slope of the graph of f at x equal to s squared. Now, in our previous lectures, we did an example like this. In this case, since we are looking for slope, we have to know the value of x. So here we know the value of, we are looking for slope when x equal to negative 2, negative 1, 0, 1, and 2. Now, it will be very fast. We don't need to use the limit process. We just use, again, power rule here. So derivative of f at s will give me 2x. So here we have 2x. Derivative of f at s equal to s squared, so it will be 2x. Now, I'm looking for the slope when s is negative 2, so we substitute. When s is negative 2, we substitute the negative 2. So our slope will be negative 4. Now, when s value is negative 1, we substitute the derivative of the function, negative 1, for the x. Then when it's 0, 2 times 0 is 0. When s is 1, it will be 2 times 1, and it's 2. Now, the reason why we say it's 2 times 2 or 2 times 1, because as we saw earlier, the function is x squared. So first thing we do, we have to find the derivative of the function. S squared will give me 2x. Then any point of x, I can find the slope. So this is the graph representation of it. When it's negative 1, we have negative 2. When it's positive 1, we have 2. When it's positive 2, we have 4, etc. Because it's 2s, so 2 times 2 is 4. Now, our last rule, which is the constant multiple rule. Now, we can see the formula here, derivative. Let's say we are finding the derivative of a function f, but f at x is multiplied by c. C is a constant value. So if I'm looking for the derivative of c, which is any constant value, times a function f at x, I will leave the c, I won't touch the c, but I will find the derivative of f at x, and I'll multiply by c. So let's see an example how it works. So the same thing written here, derivative of c times s to the power n. Now the function is s to the power n. So find the derivative of s to the power n. The answer you get multiplied by c. So here we can see s to the power n, using the power rule, it will be n times x to the power n minus 1. Then we multiply everything by c. So let's see example. So this is our first example here. Here we have to use the constant rule because we have y equal to 5 divided by 2s cubed. So we are assuming 5 divided by 2 is the constant value. Our function is s cubed. So let's find the derivative of s cubed. First, we are going to rewrite our equation since s cubed is at the denominator. So it will be 5 over 2 x to the power negative 3. Now we are going to use the power rule. The answer we get, we multiply by the constant value. And that will give us negative 3 times x to the power negative 4. And that's what we have here. So we multiply the constant value 5 by 2 with negative 3x to the power negative 4 using the power rule. So we can multiply everything. 3 times negative 15 will give 3 times negative 3 will give me negative 15 over 2 s to the power negative 4. We bring s down, so we get s to the power positive 4. Now let's try the second question. Now there's a trick here. 5 over 2x to the power 3. Remember, the power 3 also affected the 2. So we can rewrite this as 2 to the power 3 will give me 8. So I'll bring 5 by 8. Then we have s to the power negative 3. Why? Because x is down. So we take it up, we change the positive to negative. Now we can find the derivative of x to the power negative 3, which will give us negative 3 times x to the power negative 3 minus 1. So negative 3 minus 1 will give me negative 4. Then here we can multiply 5 by negative 3, which will give me negative 15. We divide by 8. S to the power negative 4, we take it down, so it becomes s to the power positive 4. So another example, this is also using the constant multiple rule because we have 7 by 3. So we bring 7 by 3 as a constant value. Now s to the power negative 2 is down, so we take it up. Always, as we said earlier, always rewrite the equation so that the variables will be at the top. Now, there's no need to take a constant value at the down to the top, only the variables. So if I have s squared, the derivative of s squared will give me what? 2x. So we have 2x, then we multiply by the constant value. So we get 14x divided by 3. Our last example, y equal to 7 divided by 3x to the power negative 2. Remember, we discussed this earlier time. So again, here we have negative 2. So what we do, we change it to positive. By changing and the negative sign to positive means we bring the x up. So we get 3x to the power 2. Now 2 times, here we have 3. So 3 twice, 3 square will give us 9. Then 9 times 7 will give us 63. So that's why we have 63 here. First of all, we may have negative 2 here. So 3 to the power negative 2, s to the power negative 2. We can bring both values up. Then we get 3 to the power 2, which will give me 9. 9 times 7 will give me 63. Then s to the power 2, the derivative of it will give me 2x. Then we're going to multiply 2 by 63, and that will give us 126x. Now here we said when differentiating functions that involve radicals, you should rewrite the function with rational exponents. And I think we mentioned this earlier. So for example, y equal to, this means cube root of x. We know cube root means the exponent will be 1/3. So it's good to write it as 1/3, then we do our equation. The same example here, 1 over cube root of s raised to the power 4 is the same as writing y equal to, since the x is denominator, we bring it up, we change the exponent to negative, raised to the power 4, so the 4 is here. Cube root will be 1/3, so 3 will be down. So this example, we have y equal to square root of x. So the first thing we do, we change the radical sign to exponent. So it's s to the power half. Now, derivative of s to the power half will be half times x to the power half minus 1. So half minus 1 will give me negative half. So our final answer will be 1 over 2. Again, negative half, we bring it down, we change it to positive half. And we know exponent of half is a square root. So, excuse me. So our answer will be 1 over 2 times square root of x. Another example, we have 1 over 2 times cube root of s squared. So the first thing we have to do, again, rewrite the equation. So we have our half x squared. So we have x, the 2, cube root 1/3. So again, when we rewrite it, we have half s to the power 2/3. Then we can find the derivative. We have our constant value half. So it will be negative 2/3 times x to the power negative 2/3 minus 1. And that will give us negative 5/3. Then here we have again negative 2/3 times half. And that will give us 1/3, negative 1/3. Got the 2 can cancel the 2 here, so we have 1/3, and it's negative. Then we can also bring the negative 5/3 down, so we turn the exponent to positive. So the next example is y equal to square root of 2x. Now we can see that the square root affect both 2 and x. And we know square root of 2 is a constant value. So we bring the square root of 2 out first. Then we write the square root of x as s raised to the power half. To find the derivative of s raised to the power half, it will be half times x to the power half minus 1. So that will give us s to the power negative half. And then we have square root of 2 and times half x. Now we move the x down, so we get square root of. Now square root of 2 divided by 2 will give us square root of 2 down. So that will be the conclusion of this lecture. So again, this lectures we learn how to use the derivative rules for, again, constant and also the power rule. And that's more faster and easier way to solve derivative problem, to find a function of a derivative of a function. So again, wish everybody the best, and thank you.